This is shuttle launch control at T-minus 3 hours and holding. Approximately 1 hour and 11 minutes remaining in this built-in hold. The ice team is at the pad doing their inspections at this time and is reporting some limited ice found in on the external tank, but not of any consequence. We are now in the breakfast room at the astronaut quarters, where the STS-31 crew is having breakfast. Mission specialist Dr. Steve Hawley, who will be deploying the telescope from the remote manipulator arm. Colonel Charlie Bolden, the pilot on this mission. The commander, Lauren Shriver, for the Space Shuttle Discovery. Dr. Kathy Sullivan, mission specialist. And Navy Captain Bruce McCandless, mission specialist. The mission emblem on the cake on the breakfast table, which is Discovery with the Hubble Space Telescope on a field of planets, stars, and galaxies. After breakfast, they will receive a weather briefing and then don their flight suits and depart for the pad about 5:15 this morning. This is shuttle launch control at T-minus 3 hours and holding. Approximately 9 minutes remaining in this built-in hold. We are watching the astronauts suit up. This is Commander Lauren Shriver having his helmet attached. Shriver is an Air Force colonel and is the mission commander. Here's Marine Colonel Charlie Bolden, the pilot, also having his helmet and communications attachments completed. On the other side of the room is mission specialist Dr. Catherine Sullivan, awaiting the helmet attachment. Otherwise, her suit-up is essentially complete. Here is Navy Captain Bruce McCandless. McCandless and Kathy Sullivan will be doing the contingency EVA on this flight should one be necessary. And Dr. Steve Hawley ready to go. He will be operating the remote manipulator arm to deploy the Hubble Space Telescope on flight day 2. The crew now headed for the elevator that will take them down to the first floor, where they'll board the Astrovan for the 20-minute ride out to Pad B. The commander and the pilot, Commander Shriver and pilot Charlie Bolden, Bruce McCandless, and members of the support team that will be going out. There is the crew headed down the elevator. And momentarily we'll see them boarding the Astrovan. And numerous KSC employees usually wait by the walkway to greet them as they head out. This is a view of the orbiter access arm, and we can see our 5-member flight crew crossing from the fixed service structure into the White Room, where they will be assisted by the closeout team and other astronaut support crew members. Commander Lauren Shriver has just entered the access hatch of Discovery, assisted by closeout crew. Pilot Charlie Bolden will be next. And as they enter their seats and begin their communications checks, we'll be hearing those checks being conducted.
OTC, CDR, how do you read?
CDR, read you loud and clear. Help me.
Hey, you're loud and clear this morning.
Good morning, Lauren.
Understand. NTZ, CDR, how do you read this morning?
Read you loud and clear, Lauren. Help me.
Loud and clear. And Houston, CDR, how do you read?
CDR, Houston. Good morning, Lauren. You're loud and clear.
And you're loud and clear also, Steve.
OTC, OVCC. Go ahead. Yeah, our last crew members boarding at this time. Copy that.
Houston, MS1, radio check over.
MS1, Houston, you're loud and clear. Good morning, Bruce.
Roger, good morning. Looks like a nice day down here.
That's good. We're working on other places. OTC, OVCC. Go ahead. Yes, sir. I'll support setup 20. Side hatch closeout and white room configuration is complete. We're ready to clear the pad. Okay.
T-minus 7 minutes, 30 seconds and counting.
LSS go for orbiter access arm retract.
This arm can be re-extended in less than half a minute if that's necessary. Coming up on T-minus 5 minutes and counting.
LSS go for orbiter APU start.
And we have a go for APU start.
APU, please.
That's in work, Stanley.
Final purge sequence of the main engines is in work. We're now transferring to internal power and switching off the orbiter's ground power supply. At this point, Discovery is being powered by the onboard fuel cells. Standing by now, here is the retraction of the gaseous oxygen vent hood. The gimbling of the main engines is complete, and the aero surfaces have been verified that they are positioned for launch. The external tank now is reported to be at flight pressure.
OTC 212. Close and lock your visors and initiate your O2 flow, and you all have a good trip.
Roger that, 10 work.
Standing by now for a go for auto sequence start. T-minus 33.
Teflon clock will hold at T-minus 31 seconds due to failure.
What has happened is the ground launch sequencer would not hand off to the orbiter's computers to complete the count because the liquid oxygen fill and drain valve was showing off when it should be on.
Anthony, this is STS, the valve's closed, we're go.
There's the confirmation that we have successfully
You're in the
recycled.
the pickup terminal sequence MPS.
That's affirmative, so we'll go. We're in good shape.
Okay, you have a go to proceed.
LSS go for auto sequence start.
We are go for start.
25.
Booster hydraulic power units have started.
20.
Sound suppression water system has started.
15.
T-minus 13 seconds.
10.
T-minus 10, go for main engine start. We are go for main engine start. T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Mission Control, Houston.
Roll program.
Roger, roll, Discovery.
The roll maneuver puts the vehicle in the proper launch plane. Guidance officer confirms a good roll maneuver. Engines now throttling back. The throttle down maneuver assists in reducing the aerodynamic loads on Discovery as it passes through the area of maximum dynamic pressure. Velocity now 1,200 feet per second. Discovery downrange 3 nautical miles.
Discovery, go at throttle up.
All 3 engines now throttled back up.
Go and throttle up.
Engines at 104%. The go at throttle up call signifies that all systems are performing well. All 3 auxiliary power units look good. Discovery's velocity now 2,300 feet per second and is downrange 8 nautical miles. Standing by for SRB separation. And both solid rocket boosters have separated. Discovery's velocity now 4,300 feet per second at a downrange distance of 35 nautical miles. Booster officer reports all 3 engines stable at 104% performance.
Discovery Houston, performance is nominal. Discovery Houston, you have a go to open the doors.
Roger, Houston. Houston, Discovery.
Go ahead, Charlie.
Yeah, Ox, you guys can probably see it. Looks like that Ox booster on the left domes is kind of getting noisy, and it's tripping the caution and warning.
Roger that. Stand by, Charlie. We're talking about it. No action for you right yet.
Houston, Discovery.
Go ahead, Charlie.
Yeah, Steve, we'd like to know if we can go ahead and get a jump on KU band deploy.
That's affirmative, Charlie. You have a go for KU band deploy.
And Houston, you've probably seen all the IMU line stuff. Looks complete.
Roger that, Lauren. We've been watching you. The IMUs look good, and we concur that you're complete.
And this is Mission Control Houston at 3 hours 2 minutes into the flight of Discovery. We're now seeing payload bay views from camera A. That's on the forward bulkhead of Discovery looking aft. We're seeing the remote manipulator system arm as it is put through its paces being checked out for tomorrow's activities related to the Hubble Space Telescope.
Discovery Houston, we're getting some real good payload bay television downlink, and we see that Steve has been hard at work getting the RMS deployed.
Okay, he's getting a good start into RMS checkout right now.
Roger, Lauren.
This is Mission Control. Mission Specialist Steve Hawley continuing to take the RMS through its checkout procedures. We are looking at the end effector as it is run through the snare drive test. The end effector will be used to grapple the Hubble Space Telescope tomorrow, and will be used to release the telescope. And the end effector is about 13 inches in diameter.
Houston, Discovery.
Go ahead, Discovery.
Roger, Jim. We think RMS checkout is complete, and we think the arm is full up. We didn't see any anomalies at all.
That sounds great, Steve, and we concur. Discovery, Houston just wanted to let you know that the ground is currently configured for HST main bus activation. So we're ready when you are.
Houston, we just put the main bus power on.
Roger, Lauren. We copy.
Good morning, outer space, from all the human race. It's time to stow your sleeping gear. We know you had a blast, you're up in space at last. Now your main objective's clear. Deploy the space telescope to carry on our dreams and hopes. Space is our world. We're living our destiny. Space is our world. The spirit of discovery. Space is our world. 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 Space is our world.
Good morning, Discovery. Your wake-up music today is compliments of your training team. We want you to make them proud today.
Discovery, Houston.
Morning, Story.
Good morning, Discovery. Good morning from Bill Reeves and Orbit 1 team, and you got a go for HST deploy ops.
That's outstanding. Thank you.
Sure is.
This is Mission Control Houston. This digital animation being fed by live telemetry depicting the motion of the robot arm as Mission Specialist Steve Hawley begins to put it through its paces. This live view coming from the forward port bulkhead camera aboard Discovery gives us a look at the real thing. Steve Hawley has unberthed the arm and has begun to move it into position for grapple of the Hubble Space Telescope. This is Mission Control Houston. Our PDRS officer here in the flight control room confirms via telemetry that the Hubble Space Telescope has been grappled. This is Mission Control Houston. We're continuing to take live television from the shuttle Discovery, this from the aft flight deck of the vehicle as Mission Specialist Kathy Sullivan continues to prepare for deploy operations. At this point, beginning to set up photographic equipment on the flight deck to document the deploy activities.
Discovery, Houston.
Go ahead, Story.
You got a go to release the propellers and a go to transfer Hubble to internal power on time.
Roger that. Understand. Go for Perler release and go for transfer to internal power on time.
That's firm.
Discovery. The transferred internal power is complete. The umbilical is dead-faced, and we'll be standing by for your go for umbilical release.
Roger, Discovery. Discovery, your go for umbilical disconnect.
We copy that. Go for umbilical disconnect.
It's firm.
In this solar array deploy attitude that Discovery is in at the time, which has the sun constantly off the nose of the orbiter Discovery, the image in the majority of the field of view is reflection of the forward bulkhead in the metallic aperture door of the telescope.
You know, pitch is about 4 degrees off, attitude-wise.
Okay.
Maybe that's what's making it look like that. You're gonna pitch it up. Okay. I see you coming up. How does it look out your window as far as clearance? Because that's the only thing. Oh, you can't see. I can't see out your window either. That shows us about 2 inches starboard. Good clearance. Still looks good. And it's about 1 inch forward, but I think that may be pitch. Pitch again kind of sagged. It's 355 right now.
Sure looks like I want to go to starboard.
Starboard, yeah. I'd go ahead and do it. Because you got, over here, I can see lots of clearance. Coming starboard nicely.
Charlie coming in over your shoulder.
A little bit more.
Okay, still coming.
Okay.
What's my Z?
Okay, Z is minus 538. And it's coming up nicely.
And this is Hubble Telescope Control in Greenbelt. We have been given the go-ahead to begin commanding release of the forward latches, which hold the solar arrays in place during launch along the side of the telescope. The forward latches are on both sides, both the port and starboard side of the telescope are released simultaneously.
Discovery, no need to acknowledge. The forward latches are in motion.
Roger, Houston, we copy.
Discovery, we'll take this attitude right here. I'd like you to go free drift for PDM deploy.
Roger, free drift.
This Hubble Telescope Control Greenbelt, 1 day, 1 hour, 54 minutes mission elapsed time. Continuing to receive television through the Vandenberg tracking station. And it is clearly showing the deployment of the solar array masts with the solar array package in the stowed position. The arrays are wound much like a pair of window shades around a roller and kept in that configuration for launch. And once the primary deployment activity has been completed, the crew tweaks the attitude and replaces the vehicle in free drift, the operations team here will begin commanding the solar array blankets to unfurl.
Discovery, in order to preserve an orbit 20 release, we'd like you to get into EVA prep.
Okay, we're proceeding with that.
Thank you.
We see both high gains moving.
Thank you, Lauren.
And as Commander Lauren Shriver just confirmed what our data screens are showing here in the control center, that the motors are in operation and the two high gain antenna masts are in the process of swinging 90 degrees to the perpendicular position.
Discovery, go free drift or plus SDM deploy.
Yeah, free drift, Story. And we see first motion, looks good.
And as the crew just confirmed, we're seeing both blankets beginning to unfurl on the port side solar array.
So far we see good smooth motion both sides.
And we got TV down here, Lauren.
Roger that.
The solar arrays are driven out of their cassettes by bistems, which are at each side of the array. The bistem is visible in the television being downlinked from the spacecraft at this time. It's attached at the end of the array to a spreader bar, and the spreader bar is in turn attached to the array, which literally pulls the array out of the cassette, which held it packaged during launch.
As you can see, Story, we've got 3 panels out.
Thanks, Lauren.
When fully deployed, both of the arrays together produce about 6,000 volts, about half of which is required to operate telescope systems, and during the daylight side of the pass, the other half is used to recharge the 6 nickel hydrogen batteries. Shift Supervisor Pete Patero just checking with his control team, receiving a report that from the ground, as confirmed by the crew from orbit, the deploy activity so far is going very smoothly. We see no indications of any problems at this time.
Discovery, you can go auto burn. We're setting up for the other array.
Okay, we'll go auto burn.
That's firm. Discovery Houston.
Go ahead.
We're looking more and more like an orbit 20 release. We'd like you to press on with the EVA prep.
Okay, we copy. We'll press on with that.
Discovery, your aperture door latch is open.
Copy that, Story. Thank you. And status for you, Houston. Charlie's downstairs in the process of getting Bruce and Kathy buttoned up in the suits.
EVA copies, and we're watching the fans come on. Discovery, we'd like free drift for minus SDM deploy.
Okay, we copy free drift.
That's firm.
Okay, you're in free drift now.
Thank you.
We see motion.
So do we, Lauren.
As the blankets begin deploying, the orbital verification team is watching very closely the tension being placed on those wings so far. Looking good.
Houston, Discovery, it looks like motion stopped with just about one panel showing.
And we see that too, Lauren. The DCE is off.
This is Mission Control Houston. Flight controllers here in Mission Control Center discussing an impending deadline. Within about 13 minutes, we will reach a point of having concluded the pre-breathe, and in order to provide enough rapid response time to support an EVA, we would need to begin depressurizing the airlock in about 12 to 13 minutes from now.
The other thing I need an answer to is if I can go ahead and commit the EVA with a thought of going out and cranking it out. If whatever they're about to do fails, do they want us to just press on to back them up? We need to get on with it.
Okay, flight, I'll come back with the answer.
And I need answers now.
Flight FAO.
Go ahead.
Yeah, I don't feel comfortable waiting until after
I don't either.
6:20.
That's why I want the answers now.
Yeah, 6:20 is my drop dead time from adding up all the times.
Okay, I'm going to have them press on. All right, Capcom, tell the crew we want them to press on into EVA, and we'll stop them whenever we have to. Just quickly, we got 4 minutes on this pass.
Discovery Houston.
Discovery, go ahead.
Okay, with the panels that you got out there right now, it's not satisfactory to stay overnight. So we're going to have to move out on the EVA.
Okay, Story.
Discovery Houston.
Discovery, go ahead.
We think there may be some problem with the tension monitoring software. We've got the DCE back on. We're going to disable the tension monitoring and resend the proc to deploy the minus SDM.
Okay, hit it. Okay, Houston, we see motion.
We've got the image down here, Lauren.
At Houston, we think it's stopped.
It's fully deployed. The micro switches confirm it.
Okay.
And for Bruce and Kathy, we'd like you to stop the airlock depress at 5, please.
Okay, they copy your story, and we're at 5.5 right now.
Okay, Charlie. Houston for Lauren.
Go ahead, Houston.
You can maneuver right to the release attitude right now. That's in the cap, page 3-20.
Page 3-20 will maneuver to the release attitude.
That's firm.
Rendezvous. We're go. Fido. Go. Eagle. Go. Ecom. Go. Inco. We're go. FAO.
Go.
Max. Go. PRS. Go flight. EVA. We're go. Sergeant, you're still go? Go. GC? Go. Network go. Payloads, waiting on you.
Flight payloads, we are go.
Capcom, we have a go for release.
Discovery, go for Hubble release.
Okay, we have a go for release, and we're going to be a minute late.
Okay, Charlie.
Houston, Discovery.
Go ahead, Charlie.
Okay, Story, we've been taking marks. Residuals and ratios look good, and we'd like to go ahead and go to filter state.
We concur, Charlie.
Story, I was taking pictures. You want? I may have missed your call. You want to go ahead and do RMS power down so we can get the guys out of the airlock set up for them?
But that's at your convenience, Steve. But once we do have the RMS stowed, then we'll back out of EVA.
Okay. I'll tell you what. We'll spend just a few more minutes then getting some pictures here.
Yes, sir. Do just that.
You've been so good to me. You've been so good to me. You know you make me wanna lift my head up and throw my head back and come on now, come on now, come on now, come on now, take it easy, take it easy, take it easy, take it easy, a little bit softer now, 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 a little bit louder 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 now. Hey, 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 hey,
Good morning, Discovery. I guess you're awake after that song. There are a lot of happy people down here. We saw a great deploy yesterday, and Hubble had a good night while you were asleep.
Tell Hoot he better find that guy and sign him up from XQ that did the wake-up music.
And we're here this morning to perform student experiment 82-16 for Greg Peterson. This is an experiment designed to investigate what effects gravity-driven buoyancy may have on the behavior of an electrical arc as you observe it on the ground in 1G, say during a Jacob's Ladder experiment in high school. And that is exactly, in fact, the kind of experiment that first gave this idea to Greg. What you see on your right here, taped to the forward lockers, is the arc chamber itself, and the Aeroflex camera is set up to look into the arc. There are mirrors behind the arc so that you get, in fact, 3 different views of it. The first thing we're going to do here is photograph the arc behavior in the ambient magnetic fields of the orbiter, and we, in fact, will look at 3 different orientations. The path of the arc, as the experiment is currently placed, goes parallel to the orbiter's y-axis through the wings. We will then rotate the box and camera 90 degrees to look at the orbiter's z-axis, vertical like this, and then again we will rotate it 90 degrees and tape it on the overhead panel so that we can look at the ambient magnetic field parallel to the vehicle's z-axis.
We'll show you this a little bit. We have actually, as you can tell, turned the power on and we have actually applied a magnetic field. So we're stepping through the fields. The reason we think you see a very finely defined arc on your right is because that's the tip of a nail. The other part of the arc system is actually the round head of a nail, and we think that the arc is just, or the charge is just kind of jumping around from place to place on the head of the nail, and that's what allows it to go that way. But if you guys can get Greg to come in, he can probably tell you whether we're right or wrong. But we did notice that the behavior of the arc became more and more erratic, and its amplitude increased as the field went up. And just as they had told us pre-flight, once you put a charge into the system, it never comes out of there. So even when we go back to no field at all, we still had the erratic behavior on the arc.
Okay, thank you, Charlie. That's Hubble we're looking at, huh?
Yes, sir. And through the gyro-stabilized binoculars, I convinced myself that I could still make out the orientation of the solar rays.
Fantastic.
Aruba, Jamaica, ooh, I wanna take you. Bermuda, Bahama, come on, pretty mama. Key Largo, Montego, baby, why don't we go? Jamaica, off the Florida Keys. There's a place called Kokomo. That's where you wanna go to get away from it all. Bodies in the sand, tropical drink melting in your hand. We'll be falling in love to the rhythm of a steel drum band. Down in Kokomo, Jamaica, ooh, I wanna take you to Bermuda, Bahama, come on, pretty mama. Key Largo, Montego, baby, why don't we go down to Kokomo? You can play it fast and then we'll take it slow. That's where we wanna go. Way down to Kokomo. Martinique, that Montserrat mystique.
Good morning, Discovery. For Max Q's keyboard, that's the way that song should really be done. Your next practice is Sunday evening in the gym. Don't be late.
We're getting TV down here. Is that lightning that you see down there?
That is extreme lightning. That's correct.
Boy, you bet. CCTVs, I've never seen them pick it up like that.
This is the Hubble Telescope Control in Greenbelt. Commands have been sent up to open the aperture door. And we have confirmation that the motor is running on the door, and the door is beginning to open. And we have confirmation from the stock that the aperture door is open.
Okay, thank you, Steve.
You know what that is, I bet.
Not only what it is, but whose it is.
How much do you think it's worth to him to have it back? And it's still running, too.
Well, that watch gets 2 rides for the price of 1.
Absolutely. Story, what we wanted to do was say a little bit of well-deserved thanks to our training team who worked really so hard with us for actually quite a long time, a couple of years while I've been with the crew anyway. So we really appreciate all the long hours and late hours and all the hard work that they did. And it's really paid off, we believe. And we'd like to thank them for the little cards they gave us to read while we're here on orbit. They're very appropriate. And we'd just like to let them know that all's going well. We're feeling great, and to give Mickey our official signal.
Okay, I'm sure they're watching. If they don't happen to be right now, I will call them.
Roger.
Let me start with a little bit of a perspective comment. Many of us were assigned to this crew back in 1985 and have been working, like many others, on the telescope project for a long time to bring this mission off. And we, again, as many others, have thought numerous times about the historical significance that the advent of an observatory such as the HST would have, and how it stands in comparison to the advances of Galileo and even to the advances of Edwin Hubble's periods of observation. And in searching for some way to possibly commemorate that or betoken that during our flight, I happened upon the idea that there must be some astronomical artifact from one of the observatories Hubble worked on that we possibly could take along as a memento. And with some considerable assistance from the Smithsonian Museum, we managed to obtain this device, which is the guiding eyepiece, we are assured, from the 100-inch telescope on which Edwin Hubble did many of his observations out at Mount Wilson in California. Some of his fundamental work, in fact. We have it with us here, as I said, courtesy of the Smithsonian and the American Astronomical Society. It was, in fact, presented to the crew at the 100th anniversary meeting of the AAS back in January. It's a great pleasure to have something of such historical significance and something that so directly symbolizes Edwin Hubble's fundamental contributions to astronomy.
And you can see as Orion sets that the stars are gradually dimmed as they pass through the Earth's atmosphere, which is, of course, the problem that Earth-bound astronomers have faced for a long time. Not only does it diminish and spread out the amount of light that you can see, but additionally, the atmosphere is not transparent to all wavelengths that are of interest scientifically, and Hubble Space Telescope will be able to observe wavelengths both short and longer of the wavelengths that are visible to telescopes on the ground.
And there is nothing in the void where the bang closed the hole in the middle of it all. There's nothing in the void where the bang closed the hole in the middle of it all. There's a hole, there's a hole, there's a hole in the middle of it all. And now I'm looking for the nothing in the void where the bang closed the hole in the middle of it all. I'm looking for the nothing in the void where the bang closed the hole in the middle of it all. There's a hole, there's a hole, there's a hole in the middle of it all. There's a hole, there's a hole, assuming the theory holds. There's a hole in the middle of it all.
This is something like 8 TB tests at once. There's a certain toxin on each one of those sets of tines, and the idea is to determine whether the body's response to immune system response varies at all in 0G. Some of the body's immune response, of course, is governed by the blood system, and another level of it is controlled by the cellular structure of the body, and the objective of this experiment specifically was to look at cell-mediated immune response.
And Houston, Discovery, we're ready to close payload bay doors if you still are.
Roger that. We were just talking about that, and the fest looks good, and you have a go for payload bay door closing.
This is Mission Control. Crew's been given the go for payload bay door closing based on the possibility that weather forecasters will be able to revise the forecast downward on wind conditions for Edwards later this morning for our landing opportunity.
Discovery Houston, we've taken a look at the weather. Weatherman says it's going to hang in there. You have a go to pro to ops 302, go to maneuver to burn attitude, and a go for the burn.
Roger that. Go for the burn.
We have a sighting Discovery on the long-range optics from Vandenberg Air Force Base. Discovery's velocity now Mach 6, altitude 133,000 feet, 181 miles away from Edwards.
Discovery Houston, state vector transfer to the BFS, please.
Transfer inward.
Discovery now at 14,000 feet, making the final approach, lining up over runway 22. And Discovery is on the glide slope, converging on the center line. Coming up now for the pre-flare maneuver at 2,500 feet. Current altitude about 6,800 feet. Landing gear is down and locked. Main gear touchdown. Nose gear touchdown. Discovery rolls out on runway 22 at Edwards at the end of mission STS-31 after traveling 2,068,213 statute miles on this mission. Mechanical Systems Officer reports steady braking. The normal amount of braking is about 8 to 10 feet per second. And this detailed test objective today is designed to be a light braking or low energy braking to try out the new carbon brakes. Wheel stop.
Houston Discovery, wheel stop.
Roger that, Discovery. Welcome back. Congratulations on a super mission, and the world is looking forward to reaping the benefits of your good work over the next 15 years. Welcome back, guys, and we have no post-landing deltas.
Okay, thank you, Steve, and we sure enjoyed it also. It was great fun.
It sure looked like it.